All right, so here we have the other compound inequality foldable here, showing our and compound inequalities. Okay, so we have here x is greater than 4 and x is greater than 6 instead of the ors that we did yesterday. Okay, so yesterday we had one or the other. Now we have both of these. So x is greater than 4, so any numbers that's greater than 4, and x is less than or equal to 6. Okay, so let's put these on the graph first so we can see what it's going to look like here. So let me just write these really quickly over here. X is greater than 4 and x is less than or equal to 6. Okay, so we have these three graphs just like we did yesterday. So on the top one, I will graph this first one. X is greater than 4. So 4 is where we have our circle. It's going to be open because it is not including 4. And x is greater than, so we're going to go follow the bigger numbers. Okay, that's the first one. And then on the second one, we're going to graph x is less than or equal to 6. So over 6 is where we have our dot. It's going to be closed because it does include 6, and it's going to be less than. So we'll go this way. Okay. So because we have the and symbol here, so that basically means that we want numbers, we want values of x that satisfy both of these conditions here. So if we were to look at, say, let's pick a number 8 here. 8, we want to ask ourselves, is 8 included in both this one and this one? Okay, so we'll look at the first one. Yes, 8 is included in the x greater than 4, but in the second one, it's not included. Okay, so 8 is not going to be part of our final set. Okay, so what is going to be part of our final set are all the numbers that overlap from the first two conditions. Okay, so we have 6 is included in this first one. 6 is included in, in this x is less than or equal to 6, and it's also included in the second one. Okay, anything just over 6 is not included, but 6 is. So we're actually going to draw a closed circle over 6. Okay, and then we're not going to look at anything that is bigger than 6 because it won't be included in the second one. Okay, so let's look at going down to the left. Okay, so 5 is included, and we'll get to 4. 4 is included in this first one, but it's not included in the second one. But just above 4, so everything up to, or I guess we could say down to 4 is included, but not 4. Okay, so then we will leave an open circle around or above 4, and then we're actually just going to connect these two here in the middle. Okay, so this is what our graph is going to look like for this type of compound inequality, is only the x values that are included in both of these sets. Okay, and that's what that looks like. So because our graph is between 4 and 6, not including 4 but including 6, we're going to write that like this. So we have 4 is less than x, which is less than or equal to 6. Okay, so here we are just combining these, and we're looking at the values that overlap in these. So let's go back over here to our set builder notation. We have our inequality now that represents this type of inequality. Okay, so we open with a curly bracket, we have x such that, and then we'll just put our inequality in here. 4 is less than x, which is less than or equal to 6, and then close with the curly bracket. Okay, so that's one type, that's the first scenario that we have, just the numbers that are overlapping here. Okay, so let's look at our second one. We have x is greater than or equal to 4 and x is greater than 6. Okay, so let's write these over here. X is greater than or equal to 4, x is greater than 6. Let's zoom into these graphs here, and then let's graph each of these individually, and then together on the bottom. Okay, so x is greater than or equal to 4, so our circle is going to go above 4. It's going to be a closed dot, and we're going to go to the right for the greater than. Okay, the second one, x is greater than 6, so our circle is going to be above 6. It will be open, and then it will be going to the right here. Okay, and now we're looking for what overlaps. Okay, so these are going in the same direction, but you can see here that anything between 4 and 6, it's included in the first one, but it's not included in the second one. So we can't include anything that's less than 6. Okay, and we also cannot include 6 because it is included in the first one, but it's not included in the second one. So the way we represent that is an open circle over 6 and then going to the right. So essentially, this graph is going to look just like the graph that has the least amount of numbers on it. Okay, so the smaller of the two, because we have to overlap, we have to find what overlaps. That's what... since we have to find the numbers that are included in both, we have to go with the smaller of the two graphs. Okay, so that's the second scenario that we have here. So the way that we're going to write this is just going to be just like this inequality here. Okay, because everything in here is also included in here. There's just more in here. So we have to go with what's less. Okay, so coming back over to write this in set builder notation, we're going to have an open bracket x such that x is greater than 6 in closed bracket. Good. Okay. The last one here, we have x is less than 4 and x is greater than 6. Okay, so we have to find what's overlapping here. So let's graph the first one. X is less than 4, so 4 is going to have an open circle going to the left. And then on the second graph, we'll graph x is greater than 6. So open circle going to the right. Okay. So since we have an and statement here, we have to find what's included in this one and what's included in this one. And it turns out there is nothing overlapping here, right? So we have everything up until 4 counts for the first one, and then everything after 6 counts for the second one, but this is not included in the first one, and this is not included in the second one. So we actually have no solutions here. There are no values of x that can both be less than 4 and greater than 6. Okay, so there's no solutions here. And in set builder notation, the way that we write this is just open bracket, all values of x such that, and then you can just write in here no solution. Okay, and those are the 3 scenarios for the and compound inequalities. Okay, so go ahead and try these 6 out on the inside of your foldable, and we'll see where let me know if you have any help, and then we'll be practicing these compound inequalities a bunch later, like in class and stuff too. So do as much as you can, then we'll do a video on the actual notes, and we'll talk about interval notation, and make sure to catch your second formative also for today.